Hi folks, we're going to take a look at number 20 from page 340. And they're asking us to solve this equation. Now we look at the left hand side and we see that we have the logarithm of a logarithm of a logarithm of x, and this is all equal to 0. Okay? Now often when we see something that has these nested brackets, we tend to start from the interior and then move out to the exterior brackets. But I actually think it's going to be more useful to go in the other direction. Okay? And what we're going to do is we're going to again use that equivalency between a logarithmic expression and an exponential expression. So I want you to consider this whole thing here is the input to this logarithm base 2. Okay, and for this first step, I'll write it on the side. Think of this as log base 2 of, and I'll call this whole thing z, and that's equal to 0. Okay? So if you take this expression, you can rewrite this as an exponential expression, because remember, this is equivalent, okay, to writing base 2 exponent 0 is equal to z. So z is equal to 1. Okay? What I want you to start trying to do is to consider this without having to write it out. So think of this as 2 to the exponent of 0 is equal to the input of the logarithm. Okay? So here we have 2 exponent 0 is equal to log base 3 of log base 4 of x. Okay, so 1 is equal to log base 3 log base 4 of x. Okay, and now we're going to do the exact same thing because we have another logarithmic equation here. So here we've got base 3 to the exponent of 1 is equal to the input of my logarithm. So 3 exponent 1 is going to be equal to this input, which is log base 4 of x. So log base 4 of x is just equal to, well, 3. Okay, and lastly, now we can do it one last time. We have a third logarithmic equation here. So base 4 exponent 3 is equal to the input of the logarithm, which is x. And so x is equal to 4 exponent 3, which is 64. Okay, so again we see the usefulness of taking a logarithmic expression, which is equal to, in this case here, some number, in the first case equal to 0, and thinking of it in terms of its exponential form. Okay, so keep in mind this relationship, that when you have an equation with a logarithm equaling some number, the base represents the base of the power, the value on the other side of the equality is your exponent, and this power has a result which is just the input to your logarithm. Okay, and in this case here we just had to do it 3 times. Okay, that's it for this one.